Okay, so now we're coming back to doing our first proofs here. Part 1 and 2, we talked about everything here basically, about how to learn our definitions, postulates, and theorems, how to study and analyze examples that you see here on the videos or in the book, how to plan your own proof, and then of course I did the first example for you. So now we're just up to practice, and I'm just going to go through some videos or go through some examples and see if you can follow along. Remember, you can hit pause at any time and use that technique we talked about in the analyzing video to try and figure out what I'm doing. So I'm going to use the normal plan. I'm going to look at the diagram over here, and I'm going to look at the given. It says that the measure of RPQ is the same as the measure as RPS. So those two are the same, and angles with the same measure are congruent, so we could also say they're congruent. And that also means that ray PR is a bisector. Okay, and they want us to prove that SPQ equals 2 times one of the smaller angles, angle RPQ in this case. Okay, so it looks like something to do with angle addition postulate, or maybe something to do with bisectors, and we know in the end we're going to show that they're the same length. So start off with a statement. Can usually get started by stating the given, and then that'll work in this case. So the measure of RPQ is equal to the measure of angle RPS, and that's always the easy reason that's given. And looking at our diagram, we see that it is just a couple of big angle made up of smaller angles, so that lends itself to the angle addition postulate. So we could say that the measure of angle SPQ equals the measure of RPS plus the measure of RPQ. And the reason I can say that is because of the angle addition postulate. I guess I don't need the S there, but so ignore that. Okay, so we've got this line. I want to show that there's 2 RPQs and SPQs, so I've got that. I can substitute in right here. I can substitute RPQ in for, okay, the reason I can do that is because this is an equal sign. So now I can say that the measure of angle SPQ equals the measure of angle RPQ plus the measure of angle RPQ. So I just substituted in right here for RPS. So that's the substitution property of equality. And basically this is what I wanted to show. If I put these two together, measure of SPQ equals 2 times the measure of angle RPQ. And that's just an algebra operation, putting things together or combining like terms. And that would be the first proof. Okay, here we're looking at angles, and they say that the measure of angle ABF, so this angle right there, is equal to the measure of BCG. Okay, so those two measures are equal. That means that angles are congruent. I don't know if I'll need that later. They also say the measure of ABF is 90 degrees. So you could also change this over to the little square, and that means this one's a square. They're both right angles because right angles measure 90 degrees, so that's a definition of right angle. Okay, so that's some givens and from the diagram, and they want us to prove that line GK, that's the line over here, is perpendicular, that's the perpendicular symbol, to line AD. So these two lines are perpendicular. I might look up the definition of perpendicular and find out that the definition of perpendicular says that lines that come together and form a 90-degree angle. So it looks like I've got everything I'm going to need to make this proof. So we'll start off with our givens. Measure of angle ABF is equal to the measure of angle BCG. The measure of angle ABF is 90, and that's part of our given. So it looks like I can say that angle BCG is 90 also. And this would be the transitive property, because the transitive property says if A equals B and B equals C, then A equals C. So let's do that as our next line. Measure of angle BCG equals 90 degrees, and that's the transitive property of equality. And if this measures 90 degrees, I can say that angle BCG is a right angle. That's from the definition of right angle. Well, now I've gotten the picture here. It shows that these things do intersect, and I've shown that they intersect at a right angle. So now I can say GK is perpendicular to line AD. The diagram shows the intersection. I've proven that they come together at a right angle, and that's just the definition of perpendicular. And that's 2 more proofs. I'll continue going through these in the next video.